I'm here with Justin and Michelle again, and today we're being scientific. I got my 3D glasses on so I can do all my experiments in 3D. There you are. What we're doing today is we're going to study some ice. We've got two theories. You want to explain one of the theories? Explain one of the theories.
Well, one theory is if you take actual glasses and put them on your face. No, if you calmly like whisper and like hum into it, it'll like have one pattern. But if you scream into the other one, when it freezes, it'll have a whole other pattern. So we're gonna test that out.
Would that be like love versus hate?
It's kind of like, honestly, what it is it shows how if you put negativity into the world, what it does, and like positivity in the universe, it's kind of like a balance with that.
Which has been proven with houseplants.
Which has been proven with houseplants. Maybe we should try that with a houseplant.
Maybe we should.
So that'll be the first one, or whichever one it ends up being. And the other one is, Michelle, tell us what the other one is.
2 ice trays, 1 cold, 1 hot water, and that the hot water will freeze first.
What? Hot water freezes faster than cold water? That's just crazy. But it's science! I think we're gonna find out if it's science! Let's get our ice trays into the freezer. Let's fill them up. Okay, science, science, science.
So cold is on the right, hot is on the left. Oh, my super spoon.
Spoon man!
Cold and hot. So while that's getting hot, I will put the cold in on the right side. Thank you. I'll wait till I can't hold my finger under the, there we go. See the steam? And now we wait.
Jess is gonna explain to us the whole cup glass thing with frost and stuff like that. So, science!
Like I said, this shouldn't take too long because it's just gonna frost over, crystallize, whatever. But Michelle, if you would like to whisper sweet nothings into that glass, I will scream into this one.
Okay.
You want to all the way over like that? You look funny, but it still works. Just like entrap the sound waves, and go ahead.
And then we get it in the freezer and let's see what happens.
The whole ice thing was just like a, it was an old parlor trick, kind of like a, what do you call that, like old wives' tale?
Old wives' tale.
Yeah, but then again, my grandma also told me that if I eat watermelon seeds, that a watermelon will grow in my belly. So, theoretically, and what they say is that like because it's hot, it takes twice as much energy to freeze, so it'll freeze faster. Rather than regular cold water, it'll just, has about like twice as much time instead of twice as much effort, I think is what the thing is with that. So I do actually predict that the hot one will freeze faster. And then with the glasses, it's kind of like scientifically, like with screaming into it, it's going to be like all crackled and like webbed out and just like a gnarly looking glass. As opposed to if you just whisper into it, it'll probably just be like a frozen glass, or if it does have any kind of like frost pattern, it'll be like not as, well, just not as gnarly as the matte one, I guess, is how to put it.
Gnarly.
Gnarly, I like that word. Word of the day,
Gnarly.
Gnarly, yes.
So I think the cold is going to freeze faster, and I think the glass patterns will be exactly the same.
And I mean, obviously I know what's going on because science in 3D. I already did the math and the math said science. It's been like 30 minutes and let's see if science has happened yet.
So this is the hot, because it goes with the faucet, and the cold. And the cold is actually freezing faster.
This cold actually has like a good thin, like it gets thinner as you go up here, but it gets thicker as you go down here. It's definitely...
There are some of these that don't even have ice on them yet.
Yeah, this one, like, it's like maybe here, and then back here is like just barely. So yeah, it's definitely thought proven wrong there. And the glasses. Let's look at the glasses. Well, you can't really see, but there's definitely a lot of fingerprints. I think maybe we should have gotten them wet first.
Should we try again?
We could try again. Because all I'm seeing is fingerprints on the outside.
Yeah, fingerprints and frost.
Fingerprints and frost.
Let's get them wet and try it again.
So what we're going to try is actually like capturing the air inside, I think that would actually make a difference.
So we're gonna retry the glasses. The ice, I think the ice was pretty clear which way that was going.
Yeah.
So that theory's swept away or whatever.
Solved?
Sure. Now we're gonna get the glasses wet. We're going to do the talking, yelling thing into them again and try one more time on that, just to see if we get a different result, because science! So it's been another 25 to half an hour, and we're gonna take a look at these cups and just see what happened once they've been covered.
So once again,
Yep, these ones are harder.
yeah, that's still the cold. Cold is still definitely freezing faster than the hot.
Cold is colder than hot, or something.
Cold freezes faster. We were proven wrong. So I was right because I took the other side. So I was right on that one.
Whoa. Okay.
So what are we going with on this one?
There's really no difference. So to prove that I wasn't completely full of crap on my theory, a Japanese scientist named Masaru Emoto did actually discover that that does actually work, but you actually have to have water in it that will form the crystals outside of the glass. So that's what I was basing it off of. Let's say if we get go for 40 likes on this page, then we will definitely do this again, and we'll do Isamoto's version of it.
And if you guys are wondering why things worked a certain way, we can tell you. It all comes down to the math and the science that we put into this experiment.
Yes, exactly.
Yes! So, obviously, just math and science. Hope you guys enjoyed this video. Give us a like and
Subscribe.
She stole my line. It's like she knew what I was gonna say. Please subscribe to our channel if you haven't subscribed yet, and you guys have a great day.
Yeah, that's a pretty fine one, big guy.